Hello, in this session we will continue our discussion about eddy current. In the last class we have seen what is an eddy current. In this session or in this video, let me just summarize about the eddy current. Here we have written, when bulk pieces of conductors are subjected to changing magnetic flux, induced current are produced in them. The flow pattern of this current resembles swirling eddies in water. So these currents are called eddy currents. Now, these eddy currents are advantageous in some cases, but in some cases it has a disadvantage. Like for example, see, according to Lenz's law, what happens? The eddy current setup in the conductor flows in such a direction so as to oppose the change in magnetic flux linked with it. Now, in order to continue the change in magnetic flux linking with the conductor, some work has to be done. Because why? The eddy current opposes the very cause producing it, or it opposes the change in flux linking the coil. Now, to avoid this opposition, some work has to be done, or we can say that some energy has to be spent against the opposition of eddy currents. So this work which is spent against the opposition of eddy current appears as heat in some cases, or appears as heat in the conductors. So eddy currents produces heat in case of electrical devices like generators, transformers, etc. In the core of the transformer, the eddy current produced will cause heating of the core of the transformer. Therefore, this eddy current are disadvantage. We have, in case of transformer, generator, etc., these eddy current produces heat. Why these produce heat? Because eddy current opposes the change in magnetic flux. So to oppose this eddy current, some work has to be done, and that work which is done to oppose the eddy current flow will appear as heat in electrical devices like generators, transformers. In case of generators, transformers, etc., they produce heat. Also, if we have a metallic conductor which is moving in the magnetic field, just in this case, this I have clearly explained in my previous session. Here the conductor is under motion within the magnetic field. It is moving into and out of the field, or it is like a simple pendulum, it is swinging, and in this case the eddy current produces damping effect, and that damping is called as electromagnetic damping. One thing we can say that it produces heat in electrical devices. So eddy current produce heat in devices like electrical device like generators, transformers, etc. Second one, they produce electromagnetic damping. Eddy current produce electromagnetic damping. We have seen how it produces damping effect in case of a conductor which is moving into and out of the field, magnetic field. Now these are, if it produces heat in electrical devices, so we do not want eddy current in such cases, right? Because we do not want any loss. Now what we can do? Now, can we eliminate eddy current? No, we cannot eliminate completely the eddy current, but definitely we can minimize it. Eddy currents can be minimized. It cannot be eliminated completely, but eddy currents can be minimized. Now, how to minimize this? The eddy currents are minimized by laminating the core. I will write 2 points here which will give us an idea how to minimize this eddy current. First one is by taking the metallic core in the form of thin sheets. Attached together. And the second one is the thin sheets are laminated from one another, or I can say that laminating the core. Laminating the core, or by combining these 2 points I can write as 1 point, that I can say, if you want to write in with a single point, you can write it as by taking the metallic core in the form of thin laminated sheets attached together. The laminated core actually consists of thin metallic sheets which are insulated from one another. Let's read here. Eddy current is a localized electric current induced in a conductor by varying magnetic field, and we have seen it generates heat. Eddy current can cause power loss in transformer because it generates heat. Now, by laminating the conductor, we can reduce eddy currents. Lamination means thin sheets of magnetic material insulated from one another. So I have not written that point. Now see this. This is the bulk conductor, and now you can see the path of the eddy current here. This is the path of the eddy current. Now, by laminating the core, what do you mean by laminating the core? Laminating the core means taking thin sheets, something like this. Instead of taking a bulk piece, take thin sheets or make slices. Make slices of this bulk piece. Take thin sheets and put one sheet over the other. And also, now you insulate these sheets from one another. That is called as laminating the core. So on the whole, I can say that taking laminated core means thin metallic sheet insulated from each other. So generally they use varnish for insulation. Now laminated core means core is sliced and each piece is laminated from the next, and hence it cuts the path of the eddy current with the lamination or insulation. Now you can see the difference between these two paths of the currents. Here the path is more, whereas here the path has reduced. The eddy current still exists, but its effect is less because we have minimized the area through which this current can pass. They may ask you a question like how to minimize the eddy current. So you can write eddy current can be minimized by eddy currents can be minimized just take down this. Eddy currents can be minimized by taking laminated core comma consists of thin metallic sheet insulated from each other by varnish instead of single solid mass. Eddy currents can be minimized by taking laminated core consists of thin metallic sheet insulated from each other by varnish instead of single solid mass. And I'll continue more about eddy current in the coming class.